Bismillahirrahmanirrahim. So, our topic is Phasor mathematics and calculus. Or why do we use phasors, right? So, the short answer is phasors provide simplified mathematics. Phasors provide simplified mathematical operations. So, for example, consider this sinusoid here. V of t is equal to Vm cos omega t plus phi. So as we know, this can be represented using the real part of a complex number Vm e j phi e is power j omega t, right? And this is our phasor here for this sinusoid. So this is V bar here, E j omega t, right? Where this V bar is equal to Vm e raised power j phi, or in the polar form, this is Vm angle phi, right? So let us consider the differentiation of this sinusoid here. So let's differentiate it with respect to time. So dv by dt is equal to, this is a cosine function, so this will result in a sinusoid sine function here, and this omega term will appear here, minus omega vm sine omega t plus phi, right? So let's convert this sine function into cosine function, the transform it into corresponding cosine function. So for example, using this graphical method, we have cos here omega t, we have minus cos omega t here, and we have sine omega t here and minus sine omega t here. And if we are going from here to here, we add plus 90, right? And this is minus sine omega. So this will result in omega vm cos omega t plus phi plus 90 degrees. So like we have represented this sinusoidal function, this sinusoid using a complex number, we can similarly present again this sinusoid using a complex number. So dv by dt, this is equal to the real part of this omega vm e raised power j omega t plus phi plus 90 degrees here, right? So this can be broken down. So dv by dt will be equal to the real part of omega vm, and this is e raised power j omega t multiplied by e raised power j phi multiplied by e raised power j 90 degrees, right? So note that this e raised power j 90, let's instead put it here, e raised power j 90 degrees, according to Euler's identity, this is cos 90 degrees plus j sine 90 degrees. So cos 90 is 0, sine 90 is 1. So this is simply equal to j. So this term will reduce to simply j here, right? So we can rewrite it, dv by dt is equal to the real part of j omega vm, right, e raised power j phi and e raised power j omega t. And if you note, this is our original phasor here, right? Vm e raised power j phi. This is our this phasor representation of this sinusoid. So dv by dt is simply equal to real part of j omega this V bar here and E j omega t. So as you can see, the result in the phasor domain is simply a multiplication of the original phasor with this term j omega. So if we have a sinusoid V of t and its phasor representation is this V bar here, then the differential, the derivative of this dv, of this sinusoid dy by dt, it corresponds to into the phasor domain with this value j omega v here. This phasor here is simply multiplied by j omega here. So the differentiation operation in the time domain has been transformed into a multiplication operation in the frequency, in the phasor of frequency domain. So when we need to do a differentiation in the time domain, we can simply perform a multiplication in the phasor, in the phasor domain for the corresponding functions, right? So likewise for the integrals also, for example, if we have this function v dt, so it will correspond to the division of this v by j omega, right? So in the time domain, the integration operation corresponds to this division operation uh, in the phasor domain. So the calculus operations in the differentiation and the integration operations, calculus operations in the time domain are simply transformed to algebraic operation, algebraic addition and multiplication and division operations in the phasor domain. So this is quite a simplified approach in the phasor domain as compared to the complex operations of differentiation and integration uh, in the time domain, right? So another yes. Before we go on to the next use of phasor functions, phasors, uh, these results can be used to find the solution, steady state solution, without knowing the initial values of the variables involved in the phasor domain, right? So another use of the phasors is the addition of sinusoids. For example, if we have a sinusoid in the time domain, v1 of t is equal to v1 cos omega 1 t plus phi 1, and we have another phasor sinusoid v2 cos omega 2t plus phi 2 in the time domain. If we wanted to add these two phases, these two sinusoids, so it will be a difficult operation in the time domain, right? So instead, what we can do is we can transform them into the phasor domain, right? V1 is equal to this is Vm1 suppose, and this is Vm2 here, right? So this is Vm1 angle phi 1, and this could be V2 bar is equal to Vm2 angle phi 2, and we can simply add the phasors. This will be a simple algebraic operation, V1 plus V2, and then we can find the resultant v of t by transforming the resultant phasor into the time domain. So this is again a simplification which is provided by these phasors.